Hello everyone. Today we'll be going through IGCSE chemistry, electronic configuration of elements is today's topic, and we'll be covering according to Cambridge, Edexcel, EQ, and Oxford syllabuses. And keep in mind that this chapter is covered in three videos. One is electronic configuration of elements, which is current video, and there are two other videos, atoms and elements and isotopes, which are there in the playlist. You will have to go through these videos, all three videos, to cover this chapter. Hopefully you understand everything. Electronic configuration of elements, if you see, like for example hydrogen, we have shown over here, and number of electrons in the subshell 1s1. When we are writing 1s1, so this one is number of electrons in subshell, and S is basically subshell. We will be going into detail understanding how electrons are arranged around the nucleus, and shells and subshells, and energy levels. What are those? Electronic configuration shows how electrons are arranged in shells around the nucleus. Electrons fill the lowest energy shell first, before moving outward. So before increasing energy side is outer side. So higher the energy, electron will be outer, in an outer orbit. So this arrangement helps explain an element's reactivity and position in the periodic chart. So each shell can hold two n square electrons, where n is the shell number. Electrons occupy specific energy levels called shells. The closer the shell to the nucleus, the lower the energy level. So, closer to the shells, like this one is closer, so it will be having lower energy requirement. Lower energy electrons will be here in the inner one, and outer one will be electrons with higher energy level. Hopefully you are understanding. Then next thing we will be going through structure of the atom and shells. Shells are labeled as KLMN, or numbered as 1 2 3 4, and the first shell holds up to 2 electrons. Here also we have shown that first energy level is containing 2 electrons, and the second one is containing 8 electrons, then 18 electrons, third one and fourth one is 32 electrons. So the second 8 and third is 18, and so on. So electrons fill shells in order of increasing energy. So each shell is divided into subshells as PDF, with slightly different energies. Electrons are found in energy levels called shells. Shells closer to the nucleus have lesser energy than the further away. Now, how we are filling electrons? Electrons are filled into orbits according to the order, and there are key rules. Three key rules we can go through. One is F2 principle. Electrons fill orbitals from lowest to highest: 1s, 2s, 2p, 3s, 3p, and this is the diagram I provided. This is the structure which they are following. So 1s, then 2s, 2p, 3s, 3p, 4s, then 3d, 4p, 5s, 4d, 5p, 5s. So in this sequence. Then the second rule which we are following is Pauli exclusion principle. Each orbital holds a maximum of 2 electrons with opposite spin. And this one, you can go through this diagram. First one is correct because both are having opposite spin. They are anti-parallel, and 1s and 2s both shells there. We are showing each shell is containing 2, but their spin is important. In this one it's wrong, and this one is also spin is not uh, correct. So these two are wrong, against the Pauli exclusion principle. Then the third one is Hund's rule, and electrons occupy separate orbitals before pairing up. So we can understand with this diagram. First one is correct one, in which uh, 3 electrons are occupying different energy levels, and then the the fourth one comes to the next one. So in this one and this one, these are this is empty and one is containing two, which is wrong, and having this type of spin is also wrong, which is against Hund's rule. So we have gone through three rules. One is after principle, the second one is Pauli excluding principle, and third one is Hund's rule. The sequence of filling explains patterns in the periodic table and element properties. Electrons always fill the lowest available energy level first. This creates the most stable configuration possible. Then writing electron configuration, write the number of electrons per shell using commas. Like for example, oxygen, number of protons will be equal to number of electrons. So number of electrons will be 8. So we are writing 2 and 6. So this will be oxygen will be having in 2 in first orbit and 6 in the second one. Or in subshells notation, we can write 1s2, 2s2, and 2p4. So the same oxygen we have represented in this one. Noble gases can be used for shorthand notation. For example, helium. This is how we are writing helium. Then 2s2 and 2p4. So helium is giving 1s2 helium. So when we write this one 1s2, 2s2, 2p4. So instead of this one, we can write only helium in brackets like this and show the rest of the configuration. The outermost shell, which is valence shell, determines an element's chemical properties. So we have given here electronic distribution of some elements, important elements like lithium is having 3. So first one will be filled with the opposite spins and 2s will be having 1. And then barium, this is will be 4 electrons. So 1s2 and 2s2. Then boron will be 5. So it will be like this one 1s2, 2s2, 2p1. And carbon 6. So 1s2, 2s2, 2p2. Nitrogen will be 7. This will be electron distribution in the orbitals. And this will be 1s2, 2s2, 2p3. And the neon will be 10, which is 1s2, 2s2, and 2p6. Then sodium is 11, 1s2, 2s2, 2p6, 3s1. To write electronic configuration, we show how many electrons go into each shell and subshell also. Then patterns in the periodic table. These are like trends in periodic table. We can understand the periodic table like how different properties of elements are increasing or decreasing. Like for example, electronegativity, ionization energy, and electron affinity, atomic radii, and then non-metallic character, metallic character, atomic radius. So this is how we can understand ionization energy and electron affinity and electronegativity like this also. So in metals, non-metals, the whole periodic chart is showing trends. Elements in the same group have the same number of outer shell electrons. Periods represent how many electron shells an atom has, and transition metals have electron filling the d subshell. Periodic table like ionization energy, periodic trends like ionization energy, and atomic radius are directly linked to electron arrangements. So you need to understand the arrows like on this side electronegativity, from left to right electronegativity is increasing, ionization energy is increasing, and from right to left atomic radii is increasing, and from up to down on this side atomic radius is increasing, and from down to up ionization energy and electronegativity is increasing. Electronic configuration explains the structure of periodic table. Elements in the same group share similar outer shell configurations. we are done with the topic. Again, just to remind you, have to go through all these three videos which are there in the playlist. Thank you very much for watching. Take care. Bye.